Hello, everyone. This is Bing, a third-year computer science PhD student at Georgia Tech. Today, I'm happy to be here to present our ASONAM 20 work, Racism is a Virus, Anti-Asian Hate and Counter-Speech in Social Media During the COVID-19 Crisis. This is a joint work with Caleb, Sandeep, Diyi, Srijan from Georgia Tech, and Naren from Virginia Tech. All the codes and data are available under this website. As declared by WHO, COVID-19 is a pandemic due to its widespread all over the world, and it has caused social disruption. Among it, online hate speech has led to real-world hate crimes. For example, over 6,600 racially motivated hate accidents happened in the last year. In 2021, Atlanta shooting led to the deaths of 6 Asian women. To fight against the hate speech, a lot of efforts are made online. For example, social media campaigns are proposed to mitigate hate speech like racism is a virus and stop Asian hate in Twitch platform. But the effectiveness of counter speech is not known. Up till now, there have been enormous efforts in this area. Some will directly analyze hate speech and counter speech messages on social media, but they are not placed in the context of pandemic like COVID-19. On the other hand, some researchers study the hate speech during COVID-19 pandemic. However, counter speech is always ignored in this kind of work. To address the gap, our work aims to analyze both hate and counter speech messages simultaneously in Twitter amidst COVID-19. To bridge the gap between hate and counter speech, we have 3 questions to answer. First, if we want to study online hate and counter speech, how to create a large-scale anti-Asian hate and counter speech dataset? Second, after creating the dataset, what are the temporal and collectivity patterns of hate and counter speech tweets and users? Third, to counter hate speech, we need to know what the impact of hate and counter speech on each other is. Here, let's focus on the first question: how to create a large-scale anti-Asian hate and counter speech dataset. Now, let me present the overview of our pipeline. First, we create a keyword list related to COVID-19 hate and counter speech. Based on the keywords, we use tweets, search, and the streaming API to crawl tweets from 2020 to 2021. After getting the tweets, we annotate tweets into 3 categories: hate, counter speech, and neutral. Next, we use the labeled datasets to train a BERT-based tweet classifier. Finally, the classifier is utilized to label the whole tweets for downstream analysis. Let me explain each step one by one. We create a keyword list for tweet crawling. Here, we have 3 types of keywords. First, COVID-19 related, like coronavirus and COVID-19, to capture the context of COVID-19. Second, hate speech related, like CCP virus, to express the anti-Asian attitude. Third, counter speech related, like racism is a virus, to fight against the hate speech. After getting the list, we use the Twitter API to crawl data from January 15, 2020 to March 26, 2021. This results in 206 million tweets. To create a Twitter classifier, we need to have some annotated tweets first. Here, we have 3 groups of tweets. First, hate speech. It refers to antagonistic speech towards Asian entity, for example, person, organization, or country. For example, COVID-19 is CCP virus from China. Stay away from Chinese Wuhan flu. This tweet targets the country China. Second, counterspeech. Those are tweets that criticize hate speech and support Asian entity against hate speech. For example, the virus did inherit come from China, but coronavirus is not excuse to be racist against Asians. COVID-19 is just one type of coronavirus. This tweet provides the fact to support Asian entity against the hate speech. Finally, we have neutral groups to indicate tweets that neither convey hate or counter speech. For example, break news: White House fight against COVID-19 by relief plan. This tweet just provides some fact. Then we recruit two readers to label 3,255 tweets. We achieve an inter-reader agreement of 0.448 for hate speech and 0.59 for counter speech, a moderate value which is typical of hate speech annotation. After removing tweets where two annotators disagree, we finally have 429 hate tweets, 517 counter speech tweets, and 1,344 neutral tweets. After getting the label datasets, we start to create the classifier. Building on the existing work, we got three types of feature vectors. First, linguistic features is a 90-dimensional vector capturing the linguistic and writing styles. Second, hashtag features records the number of occurrences of each hashtag, which are mentioned in the provided keyword list. Third, we use BERT embedding to extract the semantic meaning such that the generated vector can represent the tweet. After generating the feature vectors, we use one-layer feed-forward neural network as the final classifier. As we can see in the table, compared to linguistic and hashtag features, BERT fine-tuned model is the best with the highest F1 score. Moreover, using the tweet classifier with the BERT model, we can prevent the model from being overly reliant on the presence of specific hashtags or keywords whose popularity may change over time. Thus, we use the trained BERT fine-tuned model to label the list of tweets in the datasets. Beyond tweets, we also focus on users who send tweets. Specifically, we have four types of users: hateful users who have at least one hate tweet but no counter-speech tweets; counter-speech users who have at least one counter-speech tweets but no hate tweets; neutral users do not have any hate or counter-speech tweets but at least one COVID-19 related tweet; and finally, dual users who tweet both hate and counter-speech messages. Furthermore, we create the user network by the followee and follower relationship in Twitter platform. Here we provide the data statistics for tweets and users in our COVID-19 hate datasets. Specifically, we have 206 million tweets, around 1 million are hateful tweets, and 1 million are counter-speech tweets. Meanwhile, we have 23 million users, around 700,000 users are hateful, and around 600,000 are counter-speech users. We randomly sample some users to build the user network, which can result in 127 million nodes and 910 million edges. After getting the datasets, let's focus on the second question. What are the temporal and collectivity patterns of hate and counter-speech tweets and users. First, we analyze the ebb and flow of hate and counter-speech tweets from 2020 to 2021. As we can see, hate tweets outnumber counter-speech tweets throughout the timeline during 2020. Next, the number of hate and counter-speech tweets was negligible to know during the early phase of the pandemic in January 2020 and February 2020. We observed the spike in hate in March 2020. On the other hand, counter-speech messages typically had no volume throughout 2020 compared to hate tweets. However, after the Atlanta shooting in March 2021, there was a dramatic increase in the number of counter-speech tweets. The spike in counter-speech signals the Twitter sphere, which can express sympathy and solidarity towards the Asian community. Beyond tweets, we also investigate how users interact with each other to show the user network collectivity. Specifically, we compute the probability of following hate or counter-speech users by this formula. The number of hate or counter-speech followees divided by the number of total followees. Meanwhile, we also have a baseline to indicate what would happen in the random case. Particularly, what's the possibility of random user following a hate or counter-speech users? To do it, we will shuffle the edges between the nodes in the graph for 100 times and compute the expectation value. During the shuffle, we will keep the same set of nodes and the same node degree. Here is the result. X-axis is the type of users like counter-speech users, hate users, and the y-axis indicates the probability of following counter-speech or hate users. We found nodes exhibit homomorphily, shown in the green dashed box. As we can see in the left figure, counter-speech users are 6.9 times more likely to collect to other counter-speech users compared to the baseline. Similarly, the right figure shows that hateful users collect more with other hateful users. Thus, nodes are proportionally collected to other nodes in the same group. Additionally, both hate and counter-speech nodes are more likely to collect with one another than expected, which is shown in the purple dashed box. Precisely, hateful users follow counter-speech users 4.4 times more than expected, and counter-speech users are also likely to follow hateful users compared to the baseline. Altogether, this indicates hateful and counter-speech users are highly engaged and closely interact with each other. Here, let's focus on the third question. What's the influence of hate and counter-speech on each other? Here, we want to study the question, does the exposure to hate speech make people hateful? To answer this question, we measure the impact of hateful messages of followers before the first hate speech. Specifically, we want to know what's the possibility of users turning from neutral to hateful after exposed to some hate information. This time, we will use a user's temporal exposure from followers. As shown in the figure, a tweet user can first see some followers' hate and counter-speech tweets, and then infected by this, they will send the first hate speech tweet. Next, we define the infection risk by this formula. The number of users that both have unhate exposures and then make the first hate speech tweets divided by the number of users that have unhate exposures. We compute those values at each time step and plot it to show the result. We also have a baseline to show what's the risk when a user is randomly exposed to hateful exposures. Specifically, we will shuffle the time order of the exposure and then compute the risk value. Here is the result. X-axis is the number of hate exposures, and the Y-axis indicates the infection risk. The red line is the observed results from the current datasets, and the blue line is the baseline results, which we introduced in the previous slide. As we can see, compared to the baseline, the exposure to hate speech increases the likelihood of adopting hate speech. Moreover, the likelihood of hate adoption increases with the number of exposures. It indicates that when people see more hate speech tweets, chances are high that they will be hateful and tweet some hate speech messages. Meanwhile, the effects of counterspeech on hate speech contagions is crucial to investigate, as it can shed light on potential countermeasures. Thus, we also studied the infection of counterspeech. Compared to the study of hate speech, the only difference is the risk formula. Here, we compute the number of users that both have counterspeech exposures and then make the first hate tweet divided by the number of users that have counterspeech exposures. The other part, like baseline setup, is the same. As we can see, compared to the baseline, counterspeech decreases the risk to become hateful. It shows social inhibition effects, indicating that when exposed to counterspeech messages, people will be influenced and possibly send less hate speech tweets. To sum up, in this work, we create COVID hate dataset containing tweets from January 2020 to March 2021. We annotate tweets and build the highly accurate text classifier to identify hate and counterspeech tweets. We conduct statistic, linguistic, and network analysis of tweets and users and show the countermeasure effect of counterspeech. This work is supported in part by NSF, Adobe, Facebook, Microsoft, Georgia Institute of Technology, and the Russell Sage Foundation. We thank Melody and Haoran for help in tweet annotation. Thank you for your time. If you have any questions, please feel free to contact us. All the codes and data is available at this time.